we are going to look at synthetic division of polynomials. If I'm dividing this polynomial by this binomial, when I wonder, well, how many times does x go into 3x cubed? I say 3x squared, and now I'm going to go through the whole deal where I multiply them together. And of course, I get 3x cubed minus 9x squared when I multiply that all out. And now I'm going to do the subtraction, and that gives me 2x squared. Now I say to myself, well, how many times does x go into 2x squared? And it becomes plus 2x. And when I multiply that all out, I get 2x squared minus 6x. And now I'm going to do the subtraction again. And now I'm going to end up with negative 4x. And I'm going to bring this down, plus 12. And I say to myself, well, how many times does x go into negative 4x? And of course, the answer is negative 4. And then I do the multiplication, and I get negative 4x plus 12. And with this one, fortunately, when we do the subtraction, we're going to end up with a 0 remainder. Hooray. Now, if you're like me, you're looking at it and saying, well, there is in fact a problem with that, because look at all these x squareds and x's and things like that. Really, what I want to concentrate on is just these coefficients and numbers. If we can come up with a method that simplifies managing those, we will likely make fewer mistakes as we're going through the whole problem. So, hence synthetic division. This is going to pare that down and make things easier. So let's do this synthetic division. You'll notice already things are looking better because instead of the little curly part here, we're going to make a straight part. All right, how can we pare this down and make it look a lot better? Well, let's get rid of all the variables, and we'll just assume that we know which coefficient goes with which variable because things are going to stay in order. And let's put that polynomial inside of this divising sign. Okay, next, let's take the divisor. And let's take away the x minus, and we are just going to use a 3. So there we go. This looks a lot simpler already, and I like it way better. Now, just the way this is set up with an x and the lead coefficient always being a 3, the lead coefficient actually always shows up down here. And so this is going to be our quotient. Okay, now let's take it to the next step. I am dividing it into 3, so I said it goes in 3 times. Now I multiply the 3 by 3 and I get 9. So you'll see it doesn't look all that much different from over here, but there are a few implied things going on. Now because this is a negative 3 and we were always subtracting, we've actually left this as a positive. And what we're going to do instead of subtract is adding, because it's just a little bit easier to manage our signs. It's negative 7 plus 9 is 2. Okay, now what I actually do here is I just multiply 2 by 3 because that's sort of the way it worked over here, and we're going to see what we get. And we end up with a 6. Notice that that's not much different than the way we got the 6 over here. Instead of subtracting negative 6 from negative 10, we're just going to be adding the 6 because, like I said, this is a positive 3, not a negative 3. So we end up with a negative 4. Now we're going to do exactly the same thing. We're going to multiply negative 4 by 3. The result is negative 12. And when I add these two, I get 0, which means I have a 0 remainder. And so you'll notice that down here, 3 to negative 4, we wind up with basically what was a quotient from the previous long division problem. And so if we can keep all these things straight, synthetic division, this setup takes us a lot less time.